You know that feeling when you're staring at a screen full of code and it just looks like a tangled mess of wires? You're trying to build something amazing, but the complexity is, well, it's just totally overwhelming. So, how do we fix that? Right. Does it feel like sometimes adding one tiny new feature ends up breaking three other things? It's such a common struggle, especially when you're just starting out. You begin with a simple idea, and then bam, before you know it, you're completely lost in your own creation. But what if I told you there's a really powerful way of thinking that can bring some serious order to all that chaos? And no, this isn't just another buzzword. It's a fundamental shift in how we design software, and it's called object-oriented programming, or OOP for short. Okay, so where do we even begin? Well, the core idea of OOP is actually super intuitive. It all starts with making your code mirror the real world, organizing it around the things or objects that we see and interact with every single day. So the most basic building block here is the object. At its heart, an object is simply a stand-in for a thing inside your code. It has properties, things like its color or weight, what it is, and it has methods, which are the actions it can perform, like starting up or shutting down. To make this crystal clear, let's use a simple analogy for this whole explainer: a car. See, an object isn't the idea of a car, it's a specific car, like that red sports car driving down the street right now. It has a property, its color is red, and it has a method: it can drive. Okay, but where do these specific cars even come from? I mean, they don't just pop into existence, right? They have to be built from some kind of plan. And in OOP, that plan has a very specific name. That plan is called a class. Now, a class is not the object itself. It's the blueprint. It lays out all the potential properties, like color, make, and model, and all the possible methods, like start engine or accelerate, that any object made from it is going to have. Let's think about it this way. The engineers at a car factory have this super detailed blueprint. That's the class. Now, from that one blueprint, they can make thousands of individual cars, and those are the objects. Each car is its own unique thing, but they all come from that same fundamental design, the same class. All right, now that we understand objects and classes, let's get to the really powerful part. OOP is built on four fundamental principles, or pillars, as we call them. And trust me, mastering these is the key to writing code that's clean, powerful, and way easier to manage. First up is encapsulation. The idea here is to bundle the data, the properties, and the code that works on that data, the methods, all together inside one neat little package, one object. Then you hide all the complex guts from the outside world. It's just like a car's engine, right? It's under the hood. You don't need to know how the pistons fire to turn the key and drive. That's encapsulation in a nutshell. It protects your object and makes it way, way simpler to use. Pillar number 2, abstraction, is a close cousin to encapsulation. It's all about showing only what's necessary to the user. I mean, think about driving a car. You interact with a steering wheel, a couple of pedals, and a gear shifter. That simple interface abstracts away thousands of crazy complex mechanical things happening underneath. Abstraction makes the whole thing easy to use without needing an engineering degree. Our third pillar is inheritance. And honestly, this is where OOP really starts to feel like a superpower. It lets you create a new class, let's call it a child class, that's based on a class that already exists, the parent. The child inherits all the properties and methods from the parent. So for example, a truck class could inherit everything from a general vehicle class, wheels, an engine, doors, and then just add its own unique feature, like a cargo bed. You don't have to rewrite all that code from scratch. And finally, our fourth pillar, polymorphism. I know, it sounds super complicated, but the concept is actually pretty simple. It literally means many forms. In code, it just means you could have a single action or method that does different things depending on the object it's working with. The action start engine is the same for the driver whether they're in a gas car or an electric car, but the process happening inside is completely different. This is what makes your code incredibly flexible and dynamic. So we've covered the 4 pillars, but why go through all this trouble? What makes this whole object-oriented approach so much better than just, writing code line by line? Well, the answer is simple. It's about moving from total chaos to absolute clarity. To really see the benefit, let's compare it to the older procedural way, which is really just a long list of instructions. That approach can turn into a tangled mess fast. OOP, on the other hand, is all about these self-contained objects. This modular structure makes your code drastically easier to debug, a breeze to maintain, and, thanks to inheritance, highly reusable. So let's bring this all back to you, the developer. How does knowing all this actually make you a better programmer? What's the real-world impact on your work, on your projects? The benefits are immediate. I'm serious. You build faster because you're not reinventing the wheel every single time. You troubleshoot easier because a bug in one object is contained right there and doesn't crash your whole system. Your code is way more flexible and can actually adapt to change. And this is a big one. When you're working on a team, this organized approach makes working together 100 times smoother. You know, when you boil it all down, it comes back to this one powerful idea. Modern software is incredibly complex. Your main job as a programmer isn't just to write code. It's to manage that complexity. And OOP gives you the mental framework and the tools to do exactly that. It's about building systems that are strong, scalable, and actually understandable. So at the end of the day, object-oriented programming isn't just a set of rules. It's a whole new way of thinking. It's the blueprint for building software that's clear, powerful, and built to last. The only question left is, with this blueprint in your hands, what are you going to build next?